you have a very huge data sets and you don't have a lot of labels data. How can you use those unlabeled data more efficiently for any number of tasks, right? That's what we call foundation model. Once you build that pre-trained models, you can with very low amount of data level data, you can do your task, the fine-tuning task, right? That is the aim of this foundation model. All data can be geospatial domain, even the text data, right? The data which has time informations and location informations. Location means the latitude and longitude coordinates, right, associated with that. All those data can be considered as a geospatial data. So these data are in size of less than 10,000 times higher than the text data is available, right? Because if you see the number of satellites around the globes measuring the Earth's surface continuously, right? Those data are really in huge size, right? So the challenges you see in the large language model is basically not the same in the geospatial domain. In geospatial domain, data are around 10,000 times higher than the LLM space, right? So that is really a big data problem if you consider geospatial foundation model, right? So start with the examples, how you do that. Say we want to do a crop classification problem. For the area wherever you have a label data, you need to find this HLS data, and this data is openly available from NASA's repository and also from some of this Microsoft Earth Planet computers, Google Earth Engines, and IBM also have a similar platform called Pairs. There you can go and log in and download this data, and then you have your label data. You create these 2 to 4 patches and you go for fine-tuning tasks. That is, you will use those encoder. Along with the encoders, you will use the mask autoencoder pre-training part, and then for downstream tasks, you need this 2 to 4 images, and corresponding that 2 to 4 images, you also need the label data, the pixelized format, right? Then go for fine-tuning task. So to give you example, first use case is land surface, land use, land cover mapping. Over the time, land use changes, right? So how to capture that information? So for example, we have done this small scale fine-tuning task with 552 patches of 2 to 4 by 2 to 4 across the globe, and that has around I think 8 or 9 classes: water, trees, vegetations, crop, build area, snow, clouds, and rangeland. So then, once you do this fine-tuning task, you want to see, hey, this was the actual level and this was the predicted one, right? So for different cases, you have shown this nice image. For training such model, with 6 bands, it takes 64 GPUs, right? And number of CPUs also required for data processing and all other purposes is 512. So now we have one model ready for multiple tasks, right? You have a pre-trained model that can do the segmentation, that can do for classification, that can also do for reconstruction of some of the images. Like you don't have continuous images due to cloud problem, right? With this model, you can also generate those cloud reconstruct those cloud affected pixels or values, so that you can have a continuous space and time observations from the satellite, and then those satellite data can be consumed for various applications, right? So any other such applications of using land use, land cover. And then next one, you want to see the benchmarking, right? Some of the open source data sets already out there, and they have built they have already reported such numbers. Hey, how is my accuracy with, let's say, Sentinel-1 flood 11 data? So this is open source data. You can find it in Google. So we have used that data and show for our model that, hey, can we show some better accuracy? Or accuracy means many things, like accuracy numbers or maybe computational time and resource point of view, all sort of things, right? So we have shown that, okay, with our pre-trained model, right? For example, it can be easily explained. The intersection over union, that's the measure for flat pixels. So with number of iterations, we have shown that when you use the pre-trained models or P3 model as a backbone, right? Versus other conditions where you don't use built-in models and we use other sort of things. Then the accuracy actually, the accuracy you gain is there is a lot of difference, right? So that's the benefit of using such model or build such model. And also you can see, some evaluation study, how much data is required for getting you can put a threshold at how much accuracy I need, right, versus how much data I need to accumulate, right. So we started with the original send to flood data sets and then started reducing the data set to see the trade-off between how much accuracy we are losing, right, once we start increasing the data sets, right. So even if after reduction of 87% of data set, we are not losing much, right. So that also tells you that, hey, this geospatial foundation model with a very minimal number of data points, you can do some of your fine task. Yeah, this flood cases becomes one of the popular use case because it's easy to scale and it is very relevant to detect some of these natural disasters, right? Extents and all sort of things. So we have hosted these things in the Hugging Face. Or you can, if you know some of the areas is flooded or non-flooded, right? You just upload your some of this feature data from satellite, and it will actually give you that your area is flooded or non-flooded, and if it is flooded, how much extent is flooded, all sort of information. So the last use case we want to talk about is the Banskar. Banskar is wildfire, all sort of things happens in nature, right? How it detects remotely, right? Those things also be a great use case. And from this case also we have shown that when you use our Prithvi Foundation model, then you achieve a better accuracy compared to other if you don't use the foundation model, right? I think, yeah, so if you are interested to know about more about these models, right, you read, I think I have told that 400 plus articles are there, a lot of great blogs out there. But especially if you really want to know technical details, there is a paper in archive in open source. Same title is my talk titles. You go there and explore it. And especially if you are a researcher or very interested to explore how this model work for your downstream cases or already the downstream task I have talked about, right? This is the right place. Go to the Hugging Face and you can actually explore all these models, right? The Banskar, crop classifications, flood detections, and also some of the extra demos there. So if I think quickly go to the demo part, if I can show. So this is the place, right? And let's say I want to go to the flood case. By the way, you can, if you have a compute resource, you can download all sort of things in your place and do the task. Or you can actually build some of a new task, right? These are like few examples, right? There is no limit of task limited things, right? You can also do interesting stuff, if you want to. For example, if I want to select some of this preloaded image, coming off, right? Yeah. So this is like RGB view of HLS image. And this actually tells you this is a binary classification. This flood is a very simple case, right? Whether it's flooded pixel or non-flooded pixel. So black pixels are non-flooded pixels and white pixels are basically flooded pixels, right? So if you go to Spain, there will be some preloaded images, right? This is one of the city, Barcelona, and there actually a lot of floods pixels you can see as white patches, right? Captured in US, in California there was a flood events, and this is like fluvial floods, and we can able to capture all those flood pixels. This black, all these corporate sectors also coming up with a cloud storage platform, right? So if you know about Google Earth Engine, they almost host all sort of open source satellite data, right? You just go there and do your analytics there itself, or you can also download your data from there. Microsoft has similar kind of platform, all sort of data is there. Of course, these are like commercial places. There will be terms and conditions for commercial application, but for industry, academia use case, there will be no restrictions. And IBM also has similar platform called Pairs. But if you look for original source of this data, you go to NASA's resource or European Space Agency resource, you will find all sort of satellite data from there. And actually, there is a difference between those reports versus the commercial one, because there is a great number of processing steps there. Before consume those data or even start doing some analytics on top of it, right? Those kind of processing is already done if you go to platform like Google Earth Engines or Pairs or let's say Microsoft one, right? Versus their original sources. Yeah, you have to keep it that mind.
Is there any restriction on countries who access those data?
These are global data sets. They are scanning the entire globe, 2-3 place frequencies, right? Depends on the satellite types, and there is no restriction that you cannot use the.